A.
Recording started.
Okay. Hi everyone. Today in this final project, our topic is about Titanic spaceship data analysis using machine learning models. And this data set is taken from the Kaggle competition that we have joined. And we have also updated this data set to the forum so that no one can choose our data set. We are the teammates from group 3. These are the contents that we are going to explain in this presentation, like abstract introduction, methods and methodologies, hyperparameter tuning, all the methods, like 5 algorithms that we are going to discuss in this presentation. One is a linear regression, logistic regression, random forest, and like 2 more algorithms, and the final conclusion, results, and the discussion. When it comes to the abstract, the primary goal is to develop the predictive models for classifying the passengers as either transported or not. And we are using the 5 machine learning algorithms that we have discussed, which will be implemented using artificial neural networks using TensorFlow high-level API with Keras. Our project incorporates dimension reduction of feature selection techniques and also the hyperparameter tuning and through model evaluation to ensure robustness and accuracy in productions. And the overall analysis will involve exploring the relationship between the features that understands the impact of different variables on the outcome and that presents the visualizations also. Our main aim is to contribute the rescue efforts by providing an efficient and accurate prediction of affected passengers based on the available data set. And we are also implementing the machine learning techniques including ANN that enhancing the effectiveness of predictive models for real world applications in emergency scenarios. And the introduction is about the data set that the spaceship Titanic 1. It consists of like 13,000 passengers that are transported to the alternate dimension. And also, these are the columns that we have in the data set. And the main goal is to develop the machine learning models that accurately classify the passengers based on the information. As we have discussed, the methods and the methodologies that we are going to discuss in this presentation and also in the Jupyter Notebook. The linear regression is a regression algorithm that is used for predicting a continuous developed variable based on one or more independent variables. This algorithm seeks to find the best fitting straight line that minimizes the sum of squares differences between the predicted and the actual values. And the logistic regression that is used for binary or multi-class classification tasks. This regression is also a classification algorithm that operates on the principle of probability modeling. It predicts the likelihood of an event occurrence based on one or more predictor variables. The random forest is for ensemble learning, like the decision trees. It is a versatile solution that is applicable to both the classification and the regression tasks. And and these decision trees acts as a base learners, and the algorithm constructs multiple trees during training. The k-nearest neighbors and ANN. This is an instance-based learning algorithm that is used for both classification and the regression tasks, that is operated on the principle of proximity, which classifies the data point by analyzing the majority class among its k-nearest neighbors in the feature space. The gradient boosting regressor, it is also the assemble learning type. It iteratively constructs a sequence of weak learners, usually the decision trees, each focusing on the residuals of the previous ones. And the support vector regression, it's the regression algorithm that is designed for tasks involving continuous output variables. particularly effective in cases with complex relationships that identify a hyperline that optimally represents the distribution of input data. And the methodology, the process of the final project is, first we are we are doing the data pre-processing, and then we are splitting the data and then model training using these algorithms that we have discussed, and then the model evaluation, that we are going to train models that are evaluated using various performance metrics. One is the accuracy, F1, root mean square error, ROC score, precision, recall, and the confusion matrix. These matrix help access the accuracy and the reliability of the predictions, and then finally the results and the analysis. The hyperparameter tuning is also for the ensemble models that involves optimizing the hyperparameters that govern the behavior of the individual base learners within the ensembles. Here are key considerations for the hyperparameter tuning. One is the number of estimators, and another is the tree specific hyperparameters. And the implementation, as we have discussed, the data set, first we have joined the computation and then selected the data set, and then we are pre-processing. Now let's go to the code so that we can get into it. Here is the code. The data set consists of like 1300 passengers, which was transported to an alternative dimension. It consists of like 8,000 rows and 14 columns, that each row representing a passenger's information like passenger ID, home, planet, and everything. First, we are going to import all the NumPy, Pandas, Matplot libraries that we have done in earlier projects. Also the logistic regression, train test split, and also the confusion matrix, classification report, random forest classifier, and etc. Just we are using the matplot to represent the graph between the age and the room service. Then we are using the pd.read as CSV file to get the data. Now we are using the matplot library to display the bar plot. For the home planet, you can see the Earth, Mars, and the Europa. Also, next we are training the information of the data. You can see the passenger ID, all the columns which are not null like float 64. The next steps in the analysis would involve handling missing values, exploring the distribution of numerical features, encoding categorical variables, and preparing the data for machine learning model training. Now we are seeing the information for the test information. You can see all the same columns, like we are having 13 columns with 4,277 entries. This includes a mix of data types like object and float 64. The data set exhibits missing values in several columns, like particularly in the home, planet, cabin, destination, age, VIP, etc. And now the careful pre-processing and exploration is very essential for handling missing values and preparing the data for machine learning model development. Then the data pre-processing, we are printing the train data missing values and test data missing values. You can see here all the columns. In training data, missing values are observed across various columns with the highest count in shopping mall, whereas the test data also exhibits missing values with the highest count in the food court, followed by the Curosleep name. And this addresses the missing values through imputation or other strategies which will be crucial for robust model training and evaluation. Here we are training the data set, which consists of columns, all columns. And then we are presenting the training set, but not in the test set, as it is likely to the target variable for prediction in the training phase. Now we are again importing the pandas, numpy, the simple imputer, the standard scalar ones, and the label encoder. Now we are assuming the train and test as the original data frames, and then making sure that the test and train have the same columns. Handling the missing values, you can see that strategy is equals to most frequent, and then importing the cabin separately since it is not present in the test set. You can see if cabin in train columns, we are imputing that cabin with the data frame that is fitted into the train cabin next and the column cabin. Then we are concatenating the train data that is dropped with the cabin and access is equals to 1. In the same way, we are using again the test columns. Then we are encoding the categorical variables like label encoder is equals to same label encoder, then the test and the train home planet. Here the missing values in the cabin column are handled using the most frequent strategy through simple imputer for both the training and test sets. The cabin column is imputed separately because it may not be present in the test set and the categorical variable. Again, the imputer is equals to simple imputer, same as the strategy is equals to most frequent. This is created with the strategy set to the most frequent, indicating the missing values that will be imputed with the most frequent values in the respective column. Then we are dropping the transported column before imputation. You can see the train without transported, and then we are using the data frame. Here you can see the Curosleep value counts, the X label as the home planet and the Y label as the Curosleep. You can see the plot here, the true and the false. The categorical variable home planet has been encoded and the missing values have been replaced with the most frequent values in their respective columns. Add back to the transported column after imputation, and then we are using the set visible as false. You can see the bar plot here. The column has been successfully added back in the imputed training data set named train imputed. The dataset is now ready for the further pre-processing and the development of machine learning models. Again, we are handling missing values for the test set. The missing values in the test set have been handled using the most frequent imputation strategy. Then we are encoding categorical variables like label encoder, train imputed home planet, and the test imputed home planet. Then we are having the feature scaling. That it is used for standard scalar to ensure consistent scales for machine learning models. Then the train imputed, that is used for resulting the data sets which are now encoded and suitable for training and evaluating machine learning models. Now we are dropping the irrelevant columns like passenger ID, cabin, destination, command name for the train set and the test set. As you can see here, these data sets are now well prepared for the further steps in the machine learning workflow, such as the model training, validation, and evaluation. Then we are filling these missing values on a total expenditure. You can see here the expenditure of features is equals to the room service, food court, shopping mall, spa, and VR deck. The columns of the data set, we are training, testing for all these ones, and then we are displaying the head of that. The display data in both train imputed and test imputed now include all these columns that reflects the transformation applied to the original features. Now we are converting the Boolean columns to numeric, as you can see here. Here we are also having a matplot for the age. You can see the graph here. And also now we are checking for any other remaining missing values. We are printing the missing values. Here you can see the results of it. After doing all this task, pre-processing, checking if there are any data is missing, we are using the train imputed and the test imputed. And now the models. If you can see here, we are using the linear regression, gradient boosting, accuracy score, all the results, everything. Now we are assuming the continuous target variable, which is transported like x is equals to train imputed and y is equals to train imputed. Then we are splitting the data as train test split. Then we are creating the regression models as we have discussed in the report. We are using the 5 algorithms. One is the linear regression, gradient boosting, SVR regressor, and the logistic regression. Then we are creating an ensemble regressor. You can see the voting classifier for all these algorithms, like voting is equals to soft. It's important to note that including a classifier like logistic regression in voting ensemble along regressors might be unconventional, and the choice of model should align with the nature of the target variable. Further, the ensemble's performance need to be accessed through proper evaluation metrics and also the cross validation, which is to ensure the effectiveness in the regression task. Now the main step is we are arranging the pipelines that we are creating for all these algorithms. The 5 algorithms, you can see the pipe 1, pipe 2, pipe 3, and pipe 4 and pipe 5 for all these algorithms. Like you can see here the linear regression, gradient boosting, support vector regressor, logistic regression, and artificial neural networks. The inclusion of artificial neural network classifier demonstrates flexibility in importing deep learning models along with the traditional machine learning algorithms using a unified workflow. Now we are looping through each pipeline and the label. You can see here now we are performing the cross validation and obtaining the R-squared scores using the X train, Y train. You can see the results here for all the algorithms like 10-fold cross validation. These are calculated for each model, providing a measure of how well the models explain the variance in the target variable. These R-squared values and their standard deviations are printed for each model that are giving the insight into their predictive performance with consistency of their results across different folds. The results suggest that gradient boosting regressor performs relatively well, exhibiting the highest mean R-square score among the considered models, and the SVR shows the very low performance. These scores offer variable information for model comparison and selection based on their ability to generalize to unseen data during cross validation. Now we are creating a voting ensemble classifier for random forest, gradient boosting, and AdaBoost. Here we are using the estimators. This leverages the diverse trends of individual classifiers to make more robust and accurate predictions compared to each base learners alone. Now we are performing the 10-fold cross validation and obtain ROC scores for the ensemble. Now we are using the same as X train, Y train, then printing the mean and standard deviation of these scores. You can see here the score is found to be like 0.87 with the standard deviation of 0.01, which indicates the ensemble classifier, which combines all these 3 algorithms, performs well in distributing between the positive and negative classes, showcasing the strong predictive capabilities with good consistency across different folds. The highest ROC suggests the effective discrimination and classification performance of the ensemble model. Now we are fitting the ensemble on training data. You can see here the ensemble classifier fit with the X train and Y train prediction on the test set. Then we are evaluating the ensemble on the test set. We are printing all these evaluation metrics like accuracy, precision, recall, F1 score, confusion matrix, everything that you can see the result. These metrics collectively demonstrate the ensemble's effectiveness in binary classification, highlighting a balance between the precision and solid overall performance. Now, the confusion matrix. Here, the X label is the predicted label and the Y label is the true label. In summary, the confusion matrix allows for a detailed assessment like for the correct and the incorrect predictions, the hyperparameter tuning. You can see the grid search ensemble for the X train and the Y train. These suggest that the ensemble model achieved optimal performance by combining the predictions of the base model using a weighted average. Now, the predictions on the test set using the best ensemble model, we are printing all those ones of these results like the confusion matrix E. You can see the result here. The ROC score is like 0.77, accuracy is 77, precision is 75, recall is 82. You can see the results here. Now we are plotting the ROC curves. We are setting the properties like X label is a false positive rate and Y label is a true positive rate. You can see here for all the graphs, for all the algorithms, sorry. You can see the score here. And finally, I can conclude that our analysis involved the development of evaluation of multiple machine learning models, including random forest, gradient boosting, and AdaBoost and classifier to predict the passengers being transported. The pre-process steps, including handling missing values, including the categorical variables, and also the evaluation metrics of the validation set, including accuracy, precision, recall, and F1 score, further supported the effectiveness of the ensemble model. Overall, the ensemble approach showcased a robust predictive performance, indicating its potential utility for predicting passengers' transport outcomes in a given scenario. This is the implementation that I've already explained, the results that we have already discussed. I just want to show the PPT. The confusion matrix you can see here, the graph that we have discussed, the evaluation metrics that we have discussed. This is the result that we are going to obtain in the results like precision, recall, F1 score, accuracy. This is the score that we are going to obtain after all the data analysis. The final graph of all the algorithms with its score. And the conclusion, the individual classification also showed strong power ranging from 0.85 to 0.86. Overall, this approach is very important to note that the problem context and the specific requirements may influence the choice of the final model. Thank you.
Thank you, Shravya. Thanks to all.
Thank you, Shravya.